this video, we're going to be going through prime factors and factor trees. We're going to start off with the definitions for multiples, factors, and prime numbers. Once we've got that unlocked, we're going to actually go ahead and find the prime factors using a factor tree. This topic directly relates to LCM and HCF, lowest common multiple and highest common factors. So to do those topics, you need to make sure you know this one. Let's jump into the definitions. So it's important that we know how to distinguish between multiples and factors. A lot of people get confused with this. The multiples of a given number just means a times table of that number. So the multiples of 2 would be 2, 4, 6, 8, 10, and so on. The same would go for 100. The multiples of 100 would be 100, 200, 300, and so on. A factor, on the other hand, is a number that can divide into a given number. So if we took the 100 that we had over here, what numbers would divide into 100 and give you a whole number answer? We know 10 could divide into 100 10 times. However, 9 would not be a factor of 100 because in the 9 times table, it'll take you up to 99 and then 108. So 100 isn't in the times table of 9. So 9 is not a factor of 100. Otherwise, 20 would be a factor, 2 would be a factor because you can do 100 divided by 20 and 100 divided by 2 and so on. The main thing to understand is our multiples are times table of the given number and factors are numbers that can divide into the given number. We're going to be dealing with prime factors today, so we need to know about factors and prime numbers. A prime number is a number that does not divide by anything apart from itself and 1. We've got a list of examples here. Let's take 11. The only factors 11 has is 11 and 1. The only factors 19 has is 19 and 1. And that applies to all of these numbers, making it a prime number. By nature, if you can split a number up, such as 10, into two factors such as 2 and 5, that 10 is not a prime number. However, this 5 over here is a prime number because you can't split 5 up into two different factors. The only two factors you can split up into is 5 and 1. So we know what prime numbers are. What do they mean by finding prime factors? All this means is that we take our given number, we split it up into its prime factors. That means that if you times the prime factors together, it will give you the given number. This will make more sense if you do an example together. So over here, we've got 420. The first step we do is to split it up into its factors. So from the top of my head, I know that I can do 42 times 10 to get 420. So I've split that number into two of its factors. Now, whenever we see a prime number, meaning we can't split up anymore, we have to circle it. This might not make sense now, but at the end it will. Looking at 10 and 42, I can see that they can be split up further. Let's look at 42 first though. 42 we can split into 6 and 7. The 6 we can split up into 3 and 2, but 7 on the other hand, we can't split it up into anything. The only thing that it could split up into is 7 and 1, which is what we want. So that makes 7 a prime number, which means that we're going to circle it. Now let's carry on looking at 6. We can split that into 3 and 2. And both of these numbers are also prime numbers because we can't split 3 and 2 into anything apart from 3 and 1 and 2 and 1. Let's not forget about this 10 over here. We can split this into 2 and 5. The 2 can only be split into 2 and 1. And the 5 only to 5 and 1, which makes them both prime numbers. So these are both prime numbers. So if we follow this tree along, at the end, we're always going to end up at a prime number. And we've basically found the prime factors of 420. 420 is going to be equal to all of these numbers times by each other. So we've got 5 times 2 times 7 times 2 times 3. It's good practice to put this into index form, so that's going to be 5. We've got 2 2s, so that'll be times 2 to the power of 2, 1 7 and 1 3. And that would be our answer. One thing to note, no matter what factors you choose to split 420 into, I could have split this into 120 and 2, which would be correct. But as I simplified it further, I'd end up getting these exact same prime numbers, prime factors. That's because each number has a unique set of prime factors to it. No matter what method you choose, you'll end up getting the same prime factors. We've gone through the topic, but the best way to learn is to do questions. Thankfully, we've got videos on exam questions, which you can find at the end of this video. If you enjoyed this video, make sure you like, comment, and subscribe.